Then the first order statistic, density of first order statistic is then f of x1 equal to n into 1 minus, then f of x, that is distribution is 1 minus e power minus x1 minus theta, right, whole power n minus 1 into e power minus x1 minus theta, right. So which equal to, you can write this term as n into, here 1 go cancel, then e power minus x1 minus theta power n minus 1, right, power n minus 1 into this term. It's a similar term, right, that is e power minus, here this term power n minus 1 into e power minus x1 minus theta, right. Then we can write this is n into e power minus, here n minus 1 into 1, right, that is n, it is n into x1 minus theta. Okay, this is the first order statistic in the case of truncated exponential truncated theta. Okay, so here we want to obtain the size, right, that is the size of the test. Using this we have to find out the size, right, the size of the test, alpha equal to integral over k to infinite f of x1 into dx1, right. Then substitute the value f of x and the density of first order statistic, that is n into e power minus n x1 minus theta dx1, okay, which equal to, you can take a common, you can take constant term outside, right, that is n is a constant, right. Then integral over k to infinite, then you can write these as e power minus n x1 into e power minus n into minus theta, right, that is n theta dx1. Okay, here is a under h naught, right, that is theta naught. You can write the constant term outside, that is n into e power n theta naught integral over k to infinite e power n x1 dx1. Okay, so then integrate that term, that is n d power n theta naught. What is the integration of these terms? That is e power minus n x1 divided by minus n, right, that is k to infinite, is equal to, here n will cancel, that is a minus, right, that is minus e power n theta naught. Then substitute the value of these e power minus infinite, which means minus infinite minus e power n minus k, right. Then that is e power minus, which is equal to minus e power n theta naught, which is 0, right, there is 0 minus e power minus n k, which is equal to, we can write this term together, that is minus e power n theta naught into minus e power n into k, right, minus into minus plus, right, you see, e power n theta naught minus, okay, e power n theta naught into e power minus n k, right. So you can write this as e power minus n into k minus theta naught, that is minus n into minus theta naught, right, that is theta naught. That is alpha equal to e power minus n into k minus theta naught. But here we have to find out what is the value of k, right? So we have to take log alpha equal to, what is log of e power this term? It is n into k minus theta naught, right? Which implies, then what is the value of k? K equal to theta naught minus n into theta naught minus, so you can write this term as ln alpha equal to minus nk plus n theta naught, right? It is here, then which implies k equal to n theta naught minus ln alpha whole divided by n, right? Which implies k equal to theta naught divided by ln alpha divided by n. This is the k value, right? So then we have to find out what is the power of the test, right? Power of the test, that is the expectation of phi of x1 under h1, right? Which implies the beta equal to probability of theta 1 less than x1 less than theta naught, or under h1, or what is that? K less than x1 less than infinite, right? Which implies the probability of under h1 theta 1 less than x1 less than theta naught plus probability of k less than x1 less than infinite, right? So it takes under h1, which implies the integral over, you can write these term first, right? That is probability of k integral over k to infinite f1 of x1 1 dx1 plus integral over theta 1 to theta naught f1 x1 dx1 is equal to beta, right? Which implies, what is the value of density of first order statistic? It is k to infinite n into, what's the value? N into e power minus n x1 minus theta, here under h1, right? That is a theta 1 dx1 plus integral over theta 1 to theta naught n into e power minus n x1 minus theta 1 into dx1, right? Equal to beta. So then integrate this term, which implies so here we will take common term outside, right? That is, what is the common term here? N into e power minus n into minus theta 1, right? That is n into e power n theta 1 is a constant, right? Is n into e power n theta 1, right? Then integral over k to infinite e power minus n into x1 dx1 plus, here also the constant term is n into e power n theta 1, right? That is theta 1 to theta naught e power minus n xn x1 dx1 equal to beta, right? So here this is common term, right? Then we have to take outside n to e power n theta naught into integral over k to infinite e power minus n x1 dx1 plus integral over theta 1 to theta naught e power minus n into x1 dx1 equal to beta, right? Then we have to integrate these two terms, which implies n into e power n theta 1, then the integrate term, that is e power n x1 divided by minus n integrate over k to, limit is k to infinite, right, plus the second term, that is for n x1 divided by minus n theta 1 to theta naught, right, which implies here n got cancel. Okay, then remaining e power n theta 1, here we will substitute the value for this, right, that is here e power minus n into infinite, that is a minus infinite, right, then plus minus, right, minus this term, that is e power minus n k divided by minus 1, right, here minus n, right, n got cancelled, then remaining minus 1 plus here also e power minus n theta naught minus e power minus n theta 1 divided by minus 1, right, which implies e power n theta 1, here this term 0, right, then this term got here plus, right, e power n minus nk, right, plus then this term is become, what is that, minus e power minus n theta naught plus e power minus n theta 1, right, so which implies e power, we can write this term, we can take this term inside, right, multiply by, then we multiply by this term, okay, then can get e power minus n into k minus theta 1, right, e power n theta 1 into e power minus nk is equal to e power minus n into k minus n into minus theta 1, that is n theta 1, right, minus then this term, what is that, e power minus n into theta naught minus theta 1, then plus e power n theta 1 into e power minus n theta, that is this term divided by this term, right, that is 1, right, which implies e power minus n, we know the value of k, right, what is the value of k, from size of the test we obtain the k value, that is theta naught minus ln alpha divided by n, right, that is theta naught minus ln alpha divided by n minus theta 1, right, minus this value, this is a k value, right, this k value e power n theta naught minus theta 1 plus 1, right, which implies you can write this term as e power minus n theta naught minus multiply by minus n, right, e power minus n theta naught then minus n into this term, that is plus ln alpha, right, minus n got cancelled, right, here minus and minus, then plus, and also here e power minus n into minus theta 1, right, that is plus n theta 1 minus e power minus n theta naught minus theta 1 plus 1, right, which implies you can write this term as e power minus n theta naught e power ln alpha e power n theta 1 minus e power minus n theta naught minus theta 1 plus 1, right? Which implies we can write these two down together, right? Because here n and here n is, then you can write e power minus n theta naught minus theta 1, right? And to e power ln alpha minus e power minus n theta naught minus theta 1 plus 1, which implies e power minus n theta naught minus theta 1. What is the e power ln alpha? That is alpha, right? Minus e power minus n theta naught minus theta 1 plus 1. Okay, which implies, so here e power minus n theta naught minus theta 1 here also, right? So we can write this term as a 1 plus, here 1 plus e power minus n theta naught minus theta 1 into alpha minus 1, right? You can take e power minus n theta 1 minus theta naught outside, right? Then you can write alpha minus 1 into this term, which implies 1 minus e power minus n. You can write this term as 1 minus e power minus n theta naught minus theta 1 into 1 minus alpha. So this is the power of the test. Then you have to find out what is the value of this is for the first test function, right? Phi of x1. Similarly, you have to find the size and power and k star value and beta star value in the case of phi star of x1. This is your homework. Okay, size and power of the test.